Okay, so let me just go over the notation and the derivative. If f of x is x to the 6th power, f prime of x will be, so remember the power rule, the exponent will become the coefficient, and then the new exponent will be one less. If y is x to the 10,000, the derivative also may be called y prime. It has the same idea. 10,000 is the new coefficient, and then the exponent gets subtracted by 1. 9. If y depends on t instead of x, then the derivative of y respect to t will be the same idea, 4t cubed, and then the derivative of r cubed respect to r would be 3r squared. Okay, just for fun, and this is something we will see later on, if I'm taking the derivative of r cubed respect to x, you're gonna think, what is this? And I'm gonna tell you. If the function does not depend on x and I want to take the derivative respect to x, then everything in here may be considered as constant respect to x. So this is just the same as taking the derivative of a number like 6 or pi. So this will be 0 just because it does not depend on x and I want to take the derivative of x. But look at this expression, depends on r, and I'm taking the derivative respect on r, so logically I'm applying the power rule. In here, the rule that will apply will be the constant rule. The power rule naturally applies to powers, and if you have a rational expression like this, you have to change it to a power. So because this is the reciprocal, this is just the same as having x to the negative 2. Now I can apply the power rule. F prime, the exponent becomes the coefficient, and then x has the new exponent, which is 1 less than negative 2. So 1 less than negative 2 is negative 3. Okay, pay attention. You probably were thinking negative 1, and that's a very common mistake, but no, it's 1 less than this, so it's negative 3. The same idea here. F of x, I have to write this as a power of x, so this will be x to the power of 2 still, but because it's cubic root over 3. And now, taking the derivative of f, this becomes the coefficient, and then the new exponent is 1 less than that. So 1 less than 2/3 will be negative 1/3. If you don't know that by heart, you can do 2/3 minus 1 on the side and then find out the answer. The other example that I wanted to go over, and all of these examples are in the book, is how to find the tangent line and the normal line and explain what the normal line is. So I have the curve y equals x square root of x. Again, the only tools I have is the power rule and the constant rule right now. And although this does not look like a power of x, I can change it to a power of x if I pay attention. X is x, and the square root of x, you know that is x to the 1/2. I am multiplying powers with the same base, so I just add the exponents. Y equals x. 1 plus 1/2, it would be 3/2. And again, I already found what the derivative of this is. Y prime is 3/2 of x minus 1, that would be 1/2. Okay, so this is the value of the derivative, the value of the slope of the tangent line for any x. So for what x are they asking me for? If they are giving me the point, the first number is the x, the second number is the y, so they are asking me for x equals 1. So f prime of x at 1 will be 3/2 of 1 to the 1/2, and that is just 3/2. So I have the slope of this tangent line. What else do I need to write an equation? I need a point. So the tangent line has a slope 3/2, and it has a point, which is the point 1, 1 given right here. So I only have to put them together. The tangent line has equation y minus 1 equals 3/2 x minus 1. And that's a beautiful equation. Okay, so if I have a curve, the point is 1, 1. This is the tangent line, and its equation is exactly that. Now they are asking me for a normal line. Normal line to this curve at that point. A normal line is a perpendicular line to the tangent line. Remember that this symbol means perpendicular. So to this tangent line, the perpendicular would be at 90 degrees. So this is the normal line. And what is its equation? For the normal line, the point is the same because it's crossing through the same point. And remember that for lines that are perpendicular, the slopes are opposite of the reciprocal. So what would be the slope for this line? Opposite of reciprocal. And that's true for perpendicular lines. So what's the opposite of 3/2? Negative 3/2. What's the reciprocal of that? Negative 2/3. So what's the equation? Very simple. Y minus y1 equals x minus x1. And that's the normal line. And this equation. These two rules are useful as well. This just says the derivative of the addition of two functions is simply the addition of both derivatives. And the next slide says if I'm subtracting, if I'm taking the derivative of two functions that are subtracting, that is just simply the subtraction of the derivatives of both functions. So let's see how it works on the next example. I'm taking the derivative of a bunch of powers that are either adding or subtracting, combined with the product rule, the constant rule. I'm multiplying this by a constant. So derivative of x to the 8, 8x to the 7. Derivative of 12 times x to the 5th, the derivative of x to the 5th is 5x to the 4. The 5 multiplies the 12, so that becomes 60. Now remember, this will become coefficient with the 4, it will make up 16, and the new power of x is 3. 3 will become coefficient with the 10, so it will be 30, and the new exponent of x is 2. The exponent is 1, multiplies the 6, it stays the same, and x to the 0 is 1, so that's why it stays minus 6. And the derivative of a constant, which is 5, is 0. So that's it. One simple step. So if f of x is this polynomial, this will be f prime of x, or y prime, or the derivative of this expression with respect to x equals that. And there is no other work to be shown. On example 6, we're going to see a different application of the same idea. It says the tangent line is horizontal. So I know the tangent line is going to look like this. For horizontal lines, let's remember the slope is 0. So if the slope of the tangent line is 0, slope of tangent line is 0, that's the same thing as saying the derivative of the function is 0. Okay, so the first thing I have to do is find what is the derivative of this function, y prime, or I can write f of x, f prime of x, either way. It would be 4x cubed minus 12x, derivative of that is that. So I want to know when is this worth 0, for what values of x this is 0. And this is just particular to this problem. If they didn't tell you the tangent line is horizontal, then there is no reason to equal the derivative to 0. This information is translated into this fact that the derivative happens to be 0. Where is that x? So let's just remember how to solve equations. I'm going to factor the greatest common factor. So I have x squared minus 3 equals 0. Now, the zero product rule, whenever two quantities multiplying gives me 0, then one of them must be 0, or the other one is 0. From here, x equals 0, and that's that. And in here, I have x squared equals 3, So x equals two answers, remember that, plus or minus rad 3. So that means that all the points where the tangent line is horizontal have x coordinates 0, okay? I don't think the point goes through there, but it's at x equals 0, at x equals square root of 3, and at x equals negative square root of 3. I found the x values, but I don't know the y values. I don't know where the points are. I know only the x coordinate. So how do you find y when you know x? You just replace it. So when x is 0, y is 0, 0, 4. So the point 0, 4 is one of the points for which the tangent line is horizontal. So my curve could be like this or like that. Now, for x equals positive rad 3, I replace it there. So I have y equals rad 3 to the 4th minus 6 rad 3 squared plus 4. This is 9 minus these two cancel out, 18 plus 4, and I have 13 minus 18, negative 5. So the point rad 3, negative 5 is another point, and then when I substitute, what's the other one? Negative rad 3 to the 4th minus 6, negative rad 3 plus 4. This is still 9 plus 18 plus 4. So this is 13 plus 18 is 31. So the point negative rad 3, I'm sorry, it will be over here. Negative rad 3, 31 would be the other point where the slope is 0, as well as this one. I apologize for the mistake here. Any number square is still positive, so this still remains negative 18. So this is still negative 5. So I just have to change that here. So this is another point for which the derivative is 0. Negative rad 3, negative 5. As I mentioned earlier, the first derivative of distance is velocity, and the derivative of velocity is acceleration. So I just have to take the derivative of the distance twice to get acceleration. So I'm going to take the derivative twice. X prime will be 6t squared minus 10t plus 3, and if I take the derivative again respect to t, it would be 12t minus 10. So acceleration that depends on time is 12t minus 10. They are asking me in example 7 on the book, what's the acceleration at 2 seconds? So I just evaluated at 2, and that will be 12 times 2 minus 10, and that would be 14. Now you have to provide units no matter what test you're taking. So if the distance is in centimeters, when I take the derivative respect to time, that is going to be centimeters per second. So when I take the derivative respect to time again, it's going to be centimeters per second squared. So on this acceleration, the units are centimeters per second squared.